Alright, welcome everyone. Nice to see you here. My name is Alina Nastasoiu. I'm a data scientist at Deliveroo. And today I'm going to tell you a bit about telling stories with data at Deliveroo. And if you're wondering why I chose this topic, well, that's because we have a very clear mission for data science at Deliveroo. And you can see it right here. That is enabling the highest quality human and machine decision making at Deliveroo. And you will see that I highlighted human decision making because there are actually two branches of data science at Deliveroo. There are the machine learning scientists that are basically in charge of machine decision making, and there are the data scientists like myself that are in charge of human decision making. So what does a decision made by a machine mean? So for example, when you open our app, you will see a list of restaurants. That's a machine, that's an algorithm that decides which restaurants you're going to see, and that's what machine learning scientists do. Data scientists have to do with the human decision making, and that can be really, really broad. I'm going to share a couple of examples today, but you can think of things like what should our pricing structure be, what should be our features, or how we should be organizing, or should we still be investing in Google Ads for our riders, for our consumers, and for our restaurants. Things like this, very, very wide open questions. And the reason I highlighted human is that in all these projects, there's going to be a human that's going to be your stakeholder. And basically the data science job is to gather the data and make up a story that convinces that stakeholder to act based on your recommendations. So stories are really, really important. It's not just a secondary part of the job. I would say it's actually a critical part of the job. So this is why I decided to talk about stories today. And why are stories, let's say, better than bullet points? Well, there are a couple of reasons. If you don't put meat on the bones in your communication, people are going to assume that. So if you give them just a couple of bullet points, people are going to use those bullet points and make a story on their own. And the risk is that the story that they make up for themselves is not exactly the story that you want to tell. So it's better to be very articulate and tell the whole thing. The other thing is that we as humans are very hooked to stories, right? If you think about all the movies we're watching, the books we're reading, the gossip we're making, it's all about stories. So that's really something that can grab people's attention and that can make them pay attention to what you have to say. So that's another good reason. And I have an article, link for an HBR article that tells you more about it. So the rest of my presentation is going to be basically about what does a good story have to contain? What makes a good story? And I have here a picture from Robinson Crusoe, because I'm going to go back to this as an example of a story which is really well told, right? So if you think about it, it's about a guy who ends up on an island and manages to survive 20 years. It's something that you wouldn't believe, right? But the fact that they provide so many details, the story is so coherent and so well organized, that's what makes it a good story. And I have here an example. I took a note this morning, just so that I remind you, or I tell you what I mean when I say that a good story provides details. So this is a quote from the book. If you remember, at some point he ends up on this desert island, and the shipwreck is not far from the shore, so he swims to the shipwreck and he tries to bring stuff from the ship on the island. So this is only about the food and beverages chapter, because he has equally detailed accounts of the stuff he finds in terms of tools and of weapons. So let me read you what he says about the food that he finds there. So he says, bread, rice, 3 Dutch cheeses, 5 pieces of dried goat's flesh, which we lived much upon, and the little remainder of European corn, which had been laid by for some fowls, which we brought to sea with us, but the fowls were killed. There had been some barley and wheat together, but to my great disappointment, I found afterwards that the rats had eaten or spoiled it all. As for liquors, I found several bottles belonging to our skipper, in which some were cordial waters, and in all about 5 or 6 gallons of arak. So you see, he gives lots of details here. He tells you that the cheese was Dutch. He tells you why they had corn on the boat. He even tells you about the food that was not good, that he couldn't eat it. So these are plenty of details just for this minor detail in the book. And my argument is that whenever you present your story, you need all these details to make the story credible. But then too many details might be a bit overwhelming. So the next step is to make sure that they are cohesive and they are all organized so that your audience can basically ingest them. And now let me move on to some Deliveroo examples where I actually show you how this works. I hope that everyone in the room is familiar with our platform. So if you open the Deliveroo app, especially on a desktop, this is what you see, because on the phone you see this. But I'm showing the entire thing. And we have a couple of things going on here. So first of all, we have our cuisine tiles at the top. And then the first carousel, so we call these long lines of restaurants carousels. The first one, we call it the featured carousel, because this is where restaurants that pay an extra fee will be shown on top so that they have higher chances of being picked. And then below the featured carousel, we have what we call the marketer offers carousel. The label here is up to 50% off. So these are basically offers. Again, we want to show stuff that consumers might be interested at the top. And now, across the industry, what people do is that they insert ads in the marketer's offers carousel as well. Up until a couple of months ago, we didn't do that, but when we decided to make the change, we wanted to wrap that in an experiment. So we wouldn't just all of a sudden start inserting ads here. We did an experiment, so basically we had half of our traffic seeing the old version of the app with no ads here, and another version of, or another half of the traffic, another half of our consumers seeing a version where there were some ads here. I guess I already gave away the intervention, and now the question was, should we move on with this feature? Should we start introducing ads, yes or no? But in order to answer this question, people wanted details about what happened. So then my question for you would be, what kind of metrics you think would be important? What kind of metrics should we monitor to decide if we actually want to start introducing ads here, or if we were better off before without ads in our marketers' offers carousel? Any ideas?
The click-through rate?
Click-through rate for what? Because there are lots of things that you can click through.
The ads that you can directly compare, maybe each restaurant.
So the click-through for ads, that's a good one. Yeah, I mean for each restaurant it would be a bit too much detail. I know I said detail, but we have tens of thousands of restaurants, so that would be a bit too much. But click-through for ads, that's a really good one, because we're basically saying we're expanding the ads real estate, and we want to see if we get more clicks for ads, and this is how we make money. So that's a really good metric to have. Other metrics.
I guess how long you're on the site for. So if you're like turned off from seeing all the ads, if you close it quicker, then if you don't
That's a really good one. Actually, I don't have it in my list, but that's a really good one. How long you stay? Exactly. Maybe having ads down here is putting people off. Maybe you're seeing the same thing over and over, and that's not a pleasant experience, and you go away very fast. So that's a really good metric. Other ideas?
Conversion rate, like how many people actually then go and place an order?
Yeah. I don't have conversion, but I have the number of orders, so that's a really good one. And for the orders, we can be a bit more nuanced, right? So we have different types of orders. If you think about it, I keep moving it. So we have orders that come from here, that come from ads, and we have also orders that come from marketer offers. We care about this, and since we're introducing some changes here, we might want to monitor both of these types of orders, right? So this is what I'm seeing, lots of details. There are lots of metrics that we would like to check before we make the decision to do the change. And we discussed some of those metrics. I added a couple more here. Yeah, so click-through here for the marketer offers. I think there should be click-through for ads as well. We're interested in profit, right? We're for-profit company. Total orders, ad clicks. So lots of things, lots of details that we need to look at before we make a decision. But now, the other important thing is that we have to make sure that all those details make sense. So for example, if I went back to my stakeholders and I told them, you know what, the number of orders decreased in the variant where we introduced the ad, we had fewer orders because many people didn't like the experience. But then when I looked at the orders coming from the marketer's offers carousel, I tell them, no, that did not decrease. And when they ask about orders that we can attribute to an ad, I tell them, no, that didn't decrease either. That would be very odd, right? It means that something wrong happened. I mean, you have to make sure that your story squares and that there is some logic there. Or if when you analyze your data, something is missing, you have to dig deeper until you make everything square and until you have a good story to sell. Now, for the other idea I want to emphasize here, I want to propose to you a memory exercise. So on the next slide, don't worry, it's not difficult. And it's not, I'm just going to show it to you. So on the next slide, I will have a couple of letters. I will let them on for 5 seconds. And your mission will be to remember those letters, right? There's going to be just a row of letters. Just do your best, read them, try to memorize them, and we'll discuss after, okay? Okay, anyone remembers the letters? At least some. Yeah, you guys are getting there. So MD, that's an abbreviation for medical doctor. PhD, it's also an abbreviation. Did anyone get further than that?
RSVP.
RSVP, exactly. That's another good one.
Then CEO.
CEO, yeah. And the last bit?
I didn't see the last bit.
So what was your strategy? You just figured that these were acronyms.
Yeah.
Right, so that was exactly it. If the way to remember all of them is basically to make a sentence. If you use all the letters and you make this sentence, the MD and the PhD, RSVP to the CEO of IHOP, then it's very easy to remember. I bet that most of you will remember it by the end of the evening. So what's the trick here? There is very old research in psychology that shows that people have just 5 to 7 slots in their memory, so you cannot remember more than 5 things at a time, or more than 7 things at a time at tops. And if you think about each of those letters taking a space, it's very difficult to remember all of them. But the trick is to group them. So rather than having M and D, each occupying a single slot in your memory, you form MD, which you know comes from medical doctor, and that takes just 1 slot. And then you can take that even further. So if you make the entire sentence will take just 1 slot, rather than occupying all your memory slots with an individual letter. So how does this apply to our storytelling? Some of the stories that we're telling are really complex, right? That there are lots of details. And if you want your audience to be there with you, to make sense of what you're saying, it's really important that you organize your information. So make it easy for your audience, right? But don't give them just a row of letters. Don't give them information which is already grouped in nudges, which they can ingest really easily. And let me tell you how I applied this advice to the particular example we've been discussing so far. So analyzing that experiment. You remember that here we came up with lots of metrics, and you had other suggestions that I even didn't have here. So that's quite a lot. If you, let's say, you organize all these metrics in alphabetical order, and you tell people, oh yeah, there was an upward change here by 3%, and for this one there was a downward change by 2%. They will leave that meeting with a headache, and you cannot count on them making the decision based on all this information, which is not well organized. But the way I chose to do it, maybe there are better ways, was to organize all my metrics into 3 different buckets. So there was insights on orders, because we really care about orders, insights on profitability, because we also care about profitability a lot, and insights on clicks as a supportive metric, because usually clicks lead to all this. And then on the first row, I will have total orders, total profit, total clicks, and then I can drill down into the types of orders that are attributable to ads, the operational profit that comes basically from orders, but there is also profit from ad revenue. So do your best to organize the information in a way in which people can ingest it easily, and in this way they are more likely to be with you and you're more likely to get your message across, make your work count. I have so the first idea was create that narrative arch. Next, I want to acknowledge that when we tell stories with data science, many times we use numbers, right? So the data science story is very different from the Robinson Crusoe story in the sense that we have to use lots of numbers, lots of times, and numbers are sometimes very hard to communicate. So next, I'm going to tell you some tricks that are specific for Deliveroo keys, but I think they can be applied to other contexts as well when it comes to communicating numbers. So the first example I have is a power calculation. Anyone familiar with what power calculation means? Right, so let me explain a bit. Whenever we do an intervention, like the experiment I showed you before, we would split our audience 50-50 because that is the easiest way to see an effect. But sometimes, let's say we want to have an intervention that we think is good for the business. So the example I have here has to do with orders that have some faults in them. So orders can go wrong for a number of reasons. They can have a missing item. The restaurant can be late preparing the order. Something can happen with the rider and they can fail to deliver the order to our customers. So there are lots of things that can go wrong with the order. One of the one root cause of orders having some sort of problem are restaurants. So let's say we want to make an intervention where we see that some restaurants create these faulty orders really quite a lot of times. And we want to send them an email, maybe explaining them why that is a problem or giving them some tips on how they can do an improvement. And in this case, we would ideally send that email to all the restaurants. But if we send email to all the restaurants, we don't know whether it worked or not. So this is why we need to keep some restaurants in our control group, so that we can measure whether those that received the email did better than those that didn't. So on the one hand, we would like to have all the restaurants receiving the email, but on the other hand, we need a control group to measure the effect. And now, power calculation tries to answer the question, how big should the control group be? So the idea is that if your control group is really small, the effect that you're driving needs to be really large for you to be able to measure it accurately, right? We all know about statistical significance. If your control group is really, really tiny, you might end up being in a situation where you say, well, it seems there is an improvement, but it's not statistically significant. So the reason we do power calculations is to make sure that when we have a result, we're not in a situation of saying, yeah, it's inconclusive because we were underpowered, basically because we had too few restaurants in our control. That's the reason we do power calculations with all the experiments that we run at Deliveroo. And if you want to do this for your hackathon, there are power calculators on the internet. You can easily Google them and find one. The one we use at Deliveroo is an internal tool which is really more complex and allows you to do more things. So that's the context. We want to send those emails. On the one hand, we want to send the email to all the restaurants because we think it's going to do good. But on the other hand, we want to have that chunk that allows us to measure whether the intervention was useful, because by measuring that, we can learn for the future. Should we be doing this in the future? So the learning aspect is equally important. And yeah, the question is, how large should the control group be to balance these two opposing interests? And if you use an online power calculator, what it will ask of you will be, first of all, how large is your entire population? And we have data on that. And it will also ask you what is the metric before you did any intervention. So let's assume that 0.6% of the orders have this problem, right? That is what I'm going to tell the power calculator, and it will also ask me about the standard deviation. I mean, this being a binary metric, you can easily infer the standard deviation from the mean, but if it's a continuous metric, you need these three pieces of information: the entire sample, the mean of the variable before the intervention, and its variance. And then you can choose for different sizes of the control group. So here I tested for 10% and for 50%. What is the required rate in treatment? We also call this the minimum detectable effect. So basically, what this table says is the following. If our control group is just 10% of all the restaurants, we need to lower their rate, the rate of orders with defects from 0.6 to 0.54. So that's quite a large decrease. But if we are happy to have 50% of them in control, then we need to lower it only to 0.56 to be able to measure it successfully. So you see the trade-off. If we keep more of them, our intervention can be less impactful and we would still measure it. Does this make sense? So the more confidence you have that your intervention is strong, you can go with this because you're targeting all your restaurants, and if you're confident that you can hit this number, then that's the good way to do it. And this is what the online data would give you, right? You would go back to your stakeholder, and this is a mistake I used to do in the beginning. I would think that people who are in charge of making that decision know inside and out whether we should do this or that, but they are like you and like me. I have no idea which one is better, right? I mean, are we confident that with 10% we can hit this? They just wouldn't know. And if you just show them the number out of the box, you wouldn't help them that much. So one thing you can do is, again, rely on historical data. So let's say that we know, based on historical data, that about 7% of the restaurants would be responsive to any sort of message that we send them. So knowing that information, we can calculate what I call the achievable rate in treatment if 7% of the restaurants comply, because we know historically that 7% of them would be receptive. And here it's very easy to calculate this. You would just assume that 93% still have 0.6%, and the other 7% would reduce it to 0. So you get 0.55. So now it's much easier to make a decision, because with 10%, your required effect would be 0.54, which is actually lower than what you can achieve. So don't go with 10%, go with 50%, because otherwise the test will come inconclusive and you would have wasted the opportunity to learn something. Does this make sense? Mm-hmm. Just to wrap up, the idea here is, if you're going to communicate numbers, give another set of numbers that put those numbers in context. Don't expect people to read the number and have a gut feeling of whether that's a good number, a big number, or a small number. Help them out. Give them the context for them to assess what they are seeing. The next example is from a piece of work that I did not do, and I just simulated the data, so I'm not worried about sharing something I shouldn't be sharing. But the problem is actually quite general for Deliveroo, and it's representative for us. So you could think of us caring about people come back to reorder from us or not. And if you think about the factors that would influence that decision, there are two that easily come to mind. So distance travel and stacking orders. You can imagine that if somebody is really far from a restaurant, the rider will need a long time to get to the consumer. There is also a chance that the food might get cold, so the consumer is likely not to have a really good experience, so they are not really likely to come back. The other factor we had in mind was stacked orders. So we call stacked orders those orders where a rider would pick up deliveries for two customers. They would deliver to customer A first, and then they would go to customer B. And you can imagine that there is also a bit of delay in having an order stack. So we thought that these two variables would be negatively correlated with the probability that somebody came back, and we wanted to run an analysis to see how strong that correlation is. And in the event where we saw a really negative correlation, the next step would have been to try to reduce those delivery areas to see if we can improve our customers' experience. But I'm going to talk only about the first step, just figuring out how strong that correlation is. And if you think about it, this is just, you have a binary variable, does the customer regress or not? And you have a bunch of things that you care about, so you do a logistic regression, right? Out of the box, super easy, you get a ton of results here, and now you have to present your stakeholders with these numbers. We're going to look at the coefficient. They're all negative, like we expected. We're looking at the p-values, they're all 0. I made this up, so I made the data to be all statistically significant. But we know that in a logistic regression, the coefficients are really hard to interpret, right? Because we're talking about probabilities, and how do you translate distance traveled and whether the order is stacked into a probability of coming back? It's not very easy based on these numbers alone. So my recommendation was to just do a plot, right? Here we have the distance traveled, and you would take this distance traveled to be something which is representative for your data. So if none of your orders had the distance traveled more than 4 kilometers or 4 miles, don't go up to 10, right? Use the data, use the range, which is the right one for your data. And then the other two things that we care about are whether the order is not stacked or stacked, and you just plot the probabilities. So this is a much easier way in which you can convey information, and people will understand and they will see the effects for themselves rather than communicating regression coefficients. Yes?
Sorry, could you explain again what you meant by stacked orders?
By stacked orders, I mean a case in which a rider would pick up 2 orders for 2 different customers.
Oh,
and they would deliver to customer A and then to customer B.
Okay, that makes sense. Thank you.
Sure. And the other thing I want to add here is that with logistic regression, I feel that it's really, really hard to convey the coefficients into something meaningful, but you can use this even with normal regression. It doesn't necessarily need to be a logistic regression. Even with normal regression, just plotting how different levels of the variable that you're interested in are associated with the outcome will help your stakeholders a lot. I have one more class of advice to give, and that is about pictures. So in the previous example, I just mentioned that using a picture is better than using just words. And now I have a couple of tips about pictures. And the first one is actually very simple. If you use Python, I'm not sure about R. I'm not sure about R, but if you use Python, and if you don't bother to select your own colors, and if you want to plot 4 things, the 4 colors it chooses are going to be blue, orange, green, and red. And anyone wants to guess why that would be a problem? No? Color. Yeah, go
I
ahead.
mean, I'm assuming it depends on, your title, color block, right?
Oh yeah, sorry, I gave it away in the title. Exactly. The problem is that many people, I know a significant percentage of men are colorblind. So for them, the red and the blue colors will look pretty much the same. And it's so easy to fix this. You don't even have to choose your colors manually. You can just add this, Tableau colorblind 10, and it will automatically change the default colors. I mean, you can always program what colors you want it to use, but it's a bit more difficult. To draw this plot, I wrote 1 line of code, and to draw this plot, after I imported this, I also wrote 1 line of code. So it's something which might be not obvious to you, and it is such an easy fix that I think it's really worthwhile. The other tip I had, so this is something I worked on, And this data is from Looker, which is our tool for visualizing data. I hid everything so that I don't say something I shouldn't, but you can imagine that we have lots of restaurants, lots of riders, lots of consumers, and we can divide them in different types. And we would like to see the share of different types across time. And I was interested in 4 types, but the problem with these 4 types that I was interested in is that they are so imbalanced. So type 1 really is our dominant type. And then type 4 is so small that you cannot even see it here. And then, you couldn't show this to anyone. They wouldn't understand anything out of this, right? What I did in that situation was to use a logarithmic scale. So there is just a toggle button in Looker, use a logarithmic scale, and it produced this for me, which was so much easier to understand, especially since my interest was in this type 4, which was really, really tiny. And I wanted to show how tiny it is, especially compared to the dominant type. So the message here is play with scales. Look at, when you make a picture, make sure it feels right to you before you show it to somebody else. And don't show a picture that doesn't say anything, right? The other piece of advice is something I created. So I'm not sure if it happens to you, but when you work on something, you get into so many details and you feel that all those details are important and you want to communicate all of them. And I ended up creating this picture, which has lots of stuff in here, right? So the bars are, I'm not sure, do you see bars here? They are really a light gray. I can see them on my screen, but I cannot see them here. Yeah, maybe there is something with the light, but there are bars here. So there will be some bars around here, and there are the dots that you can see. And the bars represent something, total quantity of something, and the dots represent different shares. So maybe you can think of the riders we have, a particular type of riders, and the bars would be the total number of orders they delivered, and share of could be the share they had in the total orders of the market, or the share they had in orders with defects, or in orders with different profitability types, things like that. So I wanted to put all these because after I spent a day on that data, all that seemed important. And I showed this to my manager, and I just saw he was not impressed. And then I decided, you know what, I'm not going to share this because nobody can make sense out of this data. It's just too much. And also, the other thing was that I didn't have a clear story. So you see the blue dots are at the bottom and then they go up, but I didn't have a clear story for that. So I decided I was not going to show it. But I did show this one, which also seems a bit busy. The reason I'm sharing this with you is I guess I want to show a counterexample. And the message here is use the logic. Before I said don't show stuff that is too busy, this is a bit busy, but if the context requires it, then being a bit busy makes sense. So what I had here was an intervention. We had a control group and a treated group. These are restaurants, and you can see the evolution in terms of number of orders with defects over time. And this is when we sent the first email, and then there was another email sent later on. And I put this here just to suggest that you can use arrows on your plots. If you feel they are becoming too busy, help out your audience with arrows. Tell them what's going on in that specific section. And you see that I also added bars. So the lines are the rate of orders with errors. And then I also added bars with the total number of orders that they got, which makes this chart really busy. But I ended up adding those bars only after I chatted with the stakeholder, and they specifically asked for it. So they were concerned that the number of orders might not be representative. So if we're looking at these lines moving around, if that comes from a couple of hundred of orders, they're not likely to be representative. So I wanted to add the number of orders for that, and I did it only after I checked it with them. There was also some concern that the number of restaurants in treatment and control might be different. So that was another reason to add these red bars. So yeah, two messages here. Help your audience by adding arrows or any sort of extra communication you want them to take from that picture. And if the audience is already familiar with the data, I think you can go for a bit more complexity. If they're totally new to the data, keep it very simple, because one of the errors we make is to think that other people's are as knowledgeable as us about the stuff we've been working on. So don't underestimate that. Yeah, further reading, Robinson Crusoe. I've been using pictures from this book. It's available from the British Library online. So if you want to read it, great read. The other recommendation I have is a book by Steven Pinker, The Sense of Style. So this appears to be a book about how you write in English or how to use good English, which was useful for me as a non-native speaker. But the point is that Steven Pinker is a psychologist. So the book is meant to teach you how to communicate information to someone who is not really familiar with what you are familiar. So it's a really deep book. It's not just about formulate your sentences like this because this is the grammar rule and this is how you're supposed to do it. He really explains why communicating in certain ways actually makes you a better communicator. So I really like this book. The second one is a very new book. It came out this year, Making Numbers Count. It has lots of cute examples. So it's all about how you can put numbers into perspective. So if you tell someone how much sugar there is in a Coke, they would say there is as much sugar as in 4 donuts and 2 cubes of sugar. So there is this surprise element. Lots of interesting stats about the world. And this is something that my manager suggested, John Byrne Murdoch's Twitter account. He is a columnist at Financial Times, and he has really, really cool charts. So yeah, I recommend that as well. That's all I had. Let me know if you have questions. Yeah.
Hi, my name is Rhea.
Hi,
I work as a data analyst at SoftBank. I have 2 questions actually. So you showed us the logistic regression. I actually wanted to know, because my background's in data science, but I haven't started working on projects in companies. But moving into that, how would you best choose which machine learning or which algorithm to play around with, depending on the case study? For this, you said logistic regression. Is there any other ones that you would use to perhaps get insights on what the information on customer retention is, for example? Other than logistic regression, that is.
Well, in this case, because the outcome was binary, logistic regression seemed the natural fit. And to be honest, again, I didn't work on this project, a colleague of mine worked, and we were very interested in these two specific variables. So it was not really a machine learning project where you need to think about adding all the variables that you have and doing trimming and things like that. Yeah, I would say it depends from case to case, and if you're in doubt, just do more and see what resonates best, I would say.
Or I agree. We also have customer retention in our. We have it, but we do it on an analytical level over this. But I thought this was pretty cool to start off. Like the way you approached the customer retention was pretty interesting. The other one was the slide you showed about overpopulating the data. I think 4 days ago I made the same mistake about something, but I didn't realize it because obviously the stakeholder asks for something and you're trying to give the best. But what is your advice on how, because sometimes the stakeholder asks for something, but sometimes I don't think they understand what they really need. Right?
Yeah.
So it's always a trade-off there. And then they're like, if you don't show enough, they're like, oh, but I want this and this and this. If you do show too much, like I don't understand. I mean,
that's a really good question. There is a really good question. I would say use appendices. I do that all the time.
Okay.
So I tend to put let's say the aggregated information in the main slide, and then I would have appendices with disaggregated information or with things that I know they asked of me, but which I think doesn't make that much sense. I would put it in the appendix just in case they ask, but I would try to be the one who drives the story.
Okay. My last question would be, I use Tableau. never used Looker, but I've heard a lot about Looker. I don't know if you've used Tableau, but
A little bit, yeah.
which one do you think is better? I'm confused.
I have a recency bias towards Looker.
Okay.
Yeah, I didn't use Tableau long enough to be able to compare, but I'm quite happy with Looker.
Is it easier in terms of connecting data sources and then trying to build as much as you can? Because I can tell you from my experience working with Tableau, I think it's great. There's a lot you can do with it, but a lot of the things that look cool takes a lot more time to build because there's no drag and drop kind of situation at times for it. Like you have to build a calculated field to then build a button and add in your logos, etc., etc. You know, I don't know. Is Looker better that way?
It's hard for me to tell really. I mean, my own experience with Tableau was building a dashboard, and I felt there was a lot of point and click, which I found frustrating.
Yeah, that I agree with. Okay, that's it. Thank you very much.
Yeah, you're very welcome. Other questions? Right, I'll hang around a bit more in case something comes up. And,